How's it going, everybody? In this video we are going to break down how the stub routing characteristic works. And you've heard me mention it several times already throughout the series, but in this video we're actually going to dig into exactly what a stub router is, or what stub areas are, how they work, what their intention is, and what you can expect to see in the link state database as well as in the routing table, and the purpose behind them. Now, depending on how big your network is, will usually dictate how much optimization you want to employ in your environment. So, if you have a lot of routers in the area, then you're going to potentially having a large flooding domain. Now, in our case, we've only got 7 routers, so the flooding domain isn't very large. So there's only at most 3 or 4 routers per area. So, in the grand scheme of things, our environment isn't very large. Now, however, if you were to take this and you were to have hundreds of routers, I can't scale that large in a lab environment, but you could easily have that many routers in your core, or throughout your entire network, not just in your core and your edge, but you can have hundreds of routers depending on how big your environment is. Now, OSPF can scale to thousands of routes. So can EIGRP. Now, as long as you configure it right and you optimize your routing, that could easily cut down on a lot of the updating and a lot of the administrative backend that happens between routers, like the hellos and things like that are sent to all of your devices. So the idea with the stub area is to actually cut down on the amount of information in the link state database as well in the IP routing table. The idea of a stub area, or actually I should say, before I get into actually what a stub does, let me talk about topology versus network layer reachability information summarization, and we'll talk about NLRI significantly more in detail in BGP, which is coming up soon, simply for the fact that when you peer BGP, you don't always have to advertise. And we'll see when we actually get into BGP how that would work. We'll do a bunch of peerings and not actually advertise any routes. So topology summarization is achieved through areas. So hide the details of the graph looks in hide the details of how the graph looks in other areas, and then only run SPF for intra-area destinations. Areas don't hide reachability information. So the idea behind topology summarization is you can go in there and create a limitation to what you're actually going to see in the routing table. And typically what you're going to do here is this is where you're going to use the area range command. So you're going to hide what's going on in the network through that. Now, typically speaking too, you can also use stub routing and things like that, but the idea behind a network NLRI summarization is you're going to take multiple longer match prefixes and combine them into a smaller, shorter match. So OSPF summarization is implemented in 2 different ways. You have per prefix summarization, which is actually topology summarization, where you take a shorter match, or you take a longer match and you cut it up into 2 longer match routes, and you cut it down to a single shorter match. So let's say you've got 10/24 routes. What you would do, you figure out what slash notation would encompass all 10 of those routes, and then you would use an area range command to affect that. So instead of advertising 10/24s, you might advertise a single /20, and that would encompass all those routes. Now, per prefix summarization is remove all inter-area routes and replaces them with the shortest match possible, which is a default route, and this is what stub areas do. Now, what a stub basically is, let me scroll down here, and this will make more sense as we get into how the breakdown works. Filtering is enforced at the common transit point of the topology, the area border router. Only at ABRs and ASBRs are you allowed to do any type of summarization, whether it's topology or network layer reachability information, whether you're using the area range command or you're using stub commands. The ABR is the only place you can use this on. Now, the ABR controls which LSAs enter the area. Now, by default, Type 3 and or 5 are filtered depending on the type of stub. Now, type or a regular stub area. So when we're dealing with a stub area, you're going to be stopping type 5 external routes, as well as type 4 external routes. So type 4 and 5 LSAs are going to be denied from going in. Now, the reason why this is important is because if you are receiving a route into your routing table, the idea of a stub is to make sure that the end devices aren't used as transit. So the router that connects to, you're going to have an ABR that connects to between area 0 and the other router in that network. If you configure the other router in that network to be a stub router, they are only going to receive a default route for type 5 LSAs, because you're trying to cut down on the external information. A totally stubby area stops both inter-area and external routes, type 3, 4, and 5 LSAs from coming in. So the idea then is if you type in stub no summary, you're going to be pulling out any summary routes, which are going to be your type 3, 4, and 5. So type 3 and 4 are going to be ABR and ASBR summaries, as well as a type 5 LSA, which is the external LSA. So you type in stub no summary, that's the command you would use, and then you would get you would have just a default route for everything, except for intra-area routes. Anything that has to go to the ABR to reach the next hop, you're going to advertise a default route into that area, and that default route is going to point to the ABR's address, which is going to be what you would use as your exit point. And at that point, you would just say, if it's not local to your area, go ahead and just forward it to me, and I'll take care of that. I know how to get to there, so you don't have to worry about it. And that only affects the routers. If you have the ABR, it doesn't affect the ABR. It'll affect the routers that connect to the ABR in that same area. So that's how that works. And we'll get into the details of this as we go along. Not so stubby areas, or NSSAs, stop external routes but allows local redistribution into the area. So the way this usually works is if you want to prevent type 5 LSAs from being propagated into your area, but you still need to be able to redistribute routes in, you're not going to allow a type 5 LSA, but you will allow a type 7 LSA. Now, E1 and E2 are going to be your type 5 LSAs. And we talked about this earlier in understanding how the OSPF database worked in stubs and areas. In areas and LSAs. In that video, we talked about the difference between an E1 and E2 and N1 and N2. So when you're dealing with E2, that means you're just advertising a type 5 LSA into all areas, assuming that they're not a stub. When you're dealing with a not so stubby area, or an NSSA, you are going to allow redistribution in, so external routes into the local area, but as a type 7 LSA. And then once that router reaches an ABR, and you need to go from an ABR into another area, depending on how you have it set up, you may or may not be able to translate that from type 7 to type 5. And the P bit is what's used to do that. If the P bit is enabled, which is the propagate bit, if that bit is enabled, you will be able to advertise traffic from the not so stubby area into, the type 7 LSA will be able to be translated from type 7 to type 5 to the other normal areas. Now, if you have a not so totally stubby area, this is going to be the same thing as a totally stubby area. The idea behind the not so totally stubby area is you're going to stop both inter-area and external routes, but allows local redistribution. So type 7, type 1, and type 2. So type 3 and 4 and 5 are not allowed in. So we'll take a look at that as we go along. So now that we've discussed this, what I've actually done, and we'll talk about the recursion process as we go along here, but if we were to look here, this is just a pretty straightforward setup here. Let me minimize this, and this is our connection here. On router 1, I went into router 1 and I created a couple additional loopbacks. Do show IP OSPF or interface brief. So I created 3 loopbacks: loopback 1000, 1001, and 1002. Okay, and what I did with that is I went in and I created a route map. So do show run pipe section route-map. And we haven't covered route maps yet, but I'll talk about those more in detail when we get there. But the idea of a route map is basically it's a filtering technology that allows you to match on different characteristics and set different variables. So you can match, in this case, match an interface, loopback 1000, 1001, and 1002. And then all I did was I went underneath the OSPF process. I typed in redistribute connected subnets for the route map OSPF. So I'm redistributing connected, but only for loopback 1000, 1001, and 1002. So that means when we go to router 17, we type in show IP route, we're going to have 3 external routes. One from loopback 1000, 1001, and 1002. Now, the question is, can we reach those guys? So we're going to trace route, and we're going to type in 100.100.102.100. And we absolutely can reach it, and that's a good sign. That means the recursion is working correctly. So now, we want to break down how the link state database is going to work. So we're typing show IP OSPF database and hit enter. Now we're only receiving routes for area 100. But here's what we did. We received these routes in via type 5 LSA. The advertising router is 10.255.1.1. Well, who's 10.255.1.1? Well, that's router 1. If we look at router 1, we do come out here and do a show IP OSPF or OSPF and enter. You're going to see that my router ID is 10.255.1.1. So that's who's advertising it to us. So we see that. Now what we're going to do is we're going to type in show IP OSPF database for the external, and we're going to say the link. We could either type in the link ID, which is this guy, hit enter, and where we learned that from. So what we did is we went in here and we have it set up like this. We have the route, the routing bit is set, which means it can recurse to it. What we have now is this is an AS external link. This is the subnet that I'm trying to reach to. This is the advertising router. We have a metric type of 2, which is larger than any link state path. What this basically means is that it's being advertised with the default metric and a default route type. The metric type is E2, and the metric is 20. So if you look at the routing table, you'll see that it's being advertised with a cost of 20 here. So it's an OSPF learned route, and it's got a metric of 20. So the left side here is the administrative distance. The right side here is the actual cost to get there. Okay. Now, the forward address, this is used to figure out who we're going to recurse to. And what that basically means is if I am learning a route in, and the forward address is all zeros, that means I'm not going to look. I'm going to look at the advertising router to figure out how to get there. Now, what that also means is if I'm learning a route in here and I can't figure out who this is, then it's not going to be able to find the recursion. It's not going to be able to recurse back to where the traffic came from. So the idea now is, since my forward address is 0, I need to figure out the best path to 10.255.1.1. So if I do a show IP route to 10.255.1.1 or 1.0, I never advertised it. Let me advertise that real quick, because that's actually my mistake. Let's go to global config, config T, router OSPF 123, network of 10.255.1.1. So we're going to go to 16. We should be receiving the update in, and we are. I'm running a consistent debug on here, so we can always go back and double check. But on 17, we hit the up arrow, and now we're receiving that. And now let me do this. All right, so that didn't change anything, actually. And the LSA age is still going. So what we're doing is we need to find a recursion capability to go back to this guy. So what I'm going to do is I'm going to just type in the external route. I'm going to hit enter. So we have a couple different ways of getting there. The routing bit is set on all of them, which means that we can go to 10.255.1.1 for this one, the 101 route, and the 102 route. They're all telling me that I need to go to recurse to this guy. Now, if I was to do this and I was to type in the advertising router and right-click and paste that in, it's going to tell me that you can get there. you know how to recurse to that particular address. If we were to do the link ID, actually, sorry, the external, we know how to get there. 10.255.1.1. So a show IP OSPF database for the summary, and we're going to hit enter. And the what this guy is telling me here is, because this is what they refer to as an inter-area external, meaning that I have to leave my particular area to get to him. So I said I want to know how to get to 10.255.1.1. I want to know how to get there. So I have to look at my type 3 LSA database. I have to take a look at the network summary LSAs and say, okay, how do I recurse to that? This guy is saying go to 10.255.5.5. Okay, so now we're going to go to router 5. I'm going to jump out of here. I'm going to do a show IP OSPF database for 10.255.1.1. Well, actually, that's not going to work. We have to do for the external of 10.255.1.1. No, it's actually not that. It's let me see here. What is? Oh, there we are. So type 5. So external. Actually, we can do it this way. External, and I'd have to type in the advertising router to do that. So here we are. So now what we're seeing here is we have the type 5 LSA. That's good. So now what we need to do on router 5, we know how to get to. We know which router is advertising the route. Now what we need to do is we need to recurse back to figure out which way we got to go. So now what we're going to do is we're going to say from router 5, how do I get to the advertising router? And this is the external of 10.255.1.1. Okay, it's telling me that it's still going to 10.255.1.1. Okay, so now I'm like, okay, I understand that I need to get to this route to get to him, but I'm not directly connected to that router. So how do I go proceed with this? Well, if you type in the summary for the advertising router of 10.255.1.1, or be the actual summary for 100.100.100.0 or 100, or let's see what where am I learning that? Okay, I'm learning the external. So external for this guy. So now I know that I need to get to router 1. So I said, okay, let me look at the summary. And now in order to get to 10.255.1.1, right there, I need to go to 4. So I had to look at the type 3 LSA and say, okay, how do I get to him? So I need to go to router 4. And the best match is out towards this link right here. So now I go to router 4. Whoop. I go to router 4. And then I do a show IP OSPF database for the external route. And now I see that 10.255.1.1 is advertising this route. Okay. If I do a show IP or database for the router LSA of this guy, I'm okay. Now I'm in a good spot. What this is telling me is a router LSA is saying this is a intra-area route, and it's telling me this. I could just hit the here, and now what it's telling me now is from this router 10.255.1.1, I'm advertising these particular links. But notice how that I'm not learning the external routes, because they're not they're being redistributed into OSPF. So what I need to do now is I need to say, okay, for the external, I need to hit the enter key, and now I know to get to him I need to go there, but I know how to recurse to him. So now I get to router 1, and there I go. That's how I would get to it. So we've gone through the recursion process. Now what we need to do is we need to clear up router 16. We need to clear up all of these routers' link state databases, because right now 16 and 17 are they're getting bombarded with a bunch of routes that they don't need. Okay, so what we're going to do is I'm going to slide this guy over here so you guys can see it. And on 16, I'm going to go to 17. It's actually it'll be easier to read. On 17, we have this. We do a show IP route. We're receiving a bunch of routes, right? Well, what we want to do is we want to clean this up a little bit. Now, in order to clean this up, what I need to do is I need to go to router 5 and click on 5. I need to go to global config. I need to type in router OSPF 5, and I type in area 100, and if you look right here, it says stub. Okay, we do a stub command, and we do a question mark. Now, you have no summary here, and the no summary is basically going to pull all routes out of the database, and all routes out of the routing table. So I'm going to hit stub, and now what I got to do is on 16 and 17, the connection is going to go down. The reason for that is because the stub flags do not match at this point in time. So I'm going to go to 16. I need to type in area 100 and stub. Now we click on stub and we hit enter. Now notice all the floats coming in, and so now I need to hit that. Now we're going to resync. And what it's going to do is it's going to pull all of the type 5 LSAs out. And as that's running, we're going to come over here and do the same thing on 17. Config T, router, OSPF 100, or what did I use? I forgot, to be honest with you. Do show IP protocol summary. OSPF 1. So router OSPF 1 and area 100 stub. Okay, that's going to resync, so it goes down, and then it should come back up, and it looks like it did. What we need to do now is we need to type in do show IP route, and now it's up. Okay, so I was premature. So SPF is running in the back end. There it goes. So now we're good. Now what we don't have anymore is, okay, our adjacency's up. Now what we don't have anymore is, notice what we don't have. We don't have type 5 external LSAs. The E2 routes are gone, right? Now the common question I get is, well, how does it know? How does it know how to get to where it needs to go? Well, the answer is right here in front of you. We have this default route that's advertised into OSPF. It's advertised as a default route with a star by it, which means that it's going to be candidate default right here. It's a candidate default route. And it's advertising a default route saying, okay, anything else that's not any route that you don't know how to reach internally to your area, or any route that doesn't match an inter-area route, just send it to me. Router 5 says, let me have it. So what we're going to do is we're going to do and actually that changed. It was actually going to 16 for a minute there. Now we need to go to 5 because it was on 16 before. So we're going to say, okay, we're good now. So now what we need to do is we need to type in do trace to 100.100.100.100.100. We get to router 5, 4, 3, then to 1. So recursion works. We type in do show IP OSPF database. Come all the way to the bottom. Notice what's not here. We don't have any external links. We don't have any external LSAs. We just have a single bunch of network summaries, and we have this default route sitting here in the link state database, which is telling us that if you don't know how to get to it, send it to me. Okay? That's the general idea how this works. Now I've done that. Now what I can do is my link state database has gotten much smaller. So now if I was to do for the summary, I have all these routes. But notice what it's not going to do. It's going to show a default route pointing towards router 5. And that default route is going to be for any inter-area route that you don't have a route to. Router 5 sends it to me. I know how to deal with it. And then we go through all these guys. We have all these link state database or LSAs in here, and they all point to router 5. But anything you don't know what to do with, send it to router 5. Now, that's great. Now, what I'm going to show you next is how do we work on getting rid of all the routes. So let's say I don't want this. Let's say this is too messy for me. I have a really low-end router, or whatever the case might be. Maybe you're fussy about your routing tables. That's completely okay. I'm actually right there with you. My preferred way of doing this in production, that I will, I've actually argued with managers on this, that it's easier to work with, is I go to router 5. And on router 5, now this is only done on the ABR or the ASBR, is on this router, you can type in area 100 stub, and it's going to advertise a default route for all the external LSAs. Okay. What I'm going to do now is I'm going to type in this. I'm going to append no summary to this, which basically says do not send any summary LSAs, which means don't advertise a type 5 LSA. Okay. So now I'm going to type in no summary. I had to type in dash no summary, and from here I can type in no external capability, but that's outside of the scope for us, so I'm not even going to cover that. I'm going to hit enter. Now that's going to reset the neighbors, and at least it should. It's been a little while since I've studied this, but now what we're going to do is we're going to go to 16, and 16 is getting a bunch of updates. Okay. Now what we're going to do is we're going to go to 17, and okay, so our adjacency is back up. Now we're going to do a show IP OSPF show IP route. Now all we see here is for O routes, we see our intra-area routes are here, right? The 5, 16, 17, all that good stuff is there. But notice what we have for the inter-area routes. We have just that default route to 5. If we do a show IP OSPF database for anything, all we have now is our intra-area routes. So anything that's via the router LSA, type 1 LSAs, and we have a single type 3 LSA. And it's a default route pointing to router 5. So that means if I want to do a trace route to 100.100.100.100, I'm going to go to 5. Now if we go to router 4 and we type in show IP route, we're still going to have all these routes in here. We're going to know how to get to 17. We're going to know how to get to 16. That's how it knows how to get back. So that's how everything works out. So that is pretty much the epitome of how stubs work and how everything goes along. I hope this has been informative for you, and I'd like to thank you for viewing.